we are talking about the distributed systems, and specifically based on operating system and what this distribution means. We will see the high level overview of the distributed systems, and essentially we'll talk about the network or networks that are needed to interconnect them. Then the general structure of DOS, that is distributed operating system, also we'll talk about. So distributed operating system, when we have different processors. So distributed system is a collection of processors. See, these are processors. They are independent. They do not share any memory or a clock. Each processor, if you consider this to be a processor, each processor has its own local memory. And this processor, they communicate with one another through different communication media, that is networks, like the high-speed buses, telephone lines, and wireless connections. So we'll talk about the distributed systems and the networks that are needed to connect them, and the differences in operating system design between these systems, and also what is the difference between distributed operating system and the centralized systems. As we just said, that the motivation of this system or distributed system is we have loosely coupled processor. They are loosely coupled processor and they are interconnected by a communication network, and each processor, they have their own local resources and they communicate through some network. And the general structure of distributed system is like this. This is site A, this is site C, this is site B. They are utilizing a network and we have different processing units here. Okay, site C has its own resources. Now server has its own resources, so as the client, right? So they are communicating with the help of certain network on the background or as a backbone, and now these are having their own memory, and this operating system is working to make them the work possible. So what are the reasons for building distributed operating system? Why we can't only go with the normal systems, normal operating system? Why we want distributed operating system? First of all, we want resource to be shared, resource sharing. We want the computation to be, speedy. We want reliability and of course the communication. So what does this resource sharing means? A user here can use a resource from different side, like he can share file, he can process the information, he can print the file. Communication speed up. If we have a big task, let's divide it, and this subcomputation can be given to this processor, this can be given to this processor. So these processors can run concurrently, and a distributed system allow us to distribute our task or subcomputation among various sites. These are different sites or processing sites. Say if this processor is overloaded, then what we can do? This is somewhat lightly loaded, so the task can be given here. The task can be moved here. This is load sharing. Reliability. If we have only one site and if it fails, what to do? If we have multiple sites, if it fails, then this may take over, this may take over. If each machine is responsible for some important function, this will halt the system. We need to have enough redundancy. We need continued operation in present scenario. And the failure can be detected, and this system, if it is failed, it is no longer, will not use its services. If the function of the failed site, it can be taken over by another site, and this transferring of, or you can say moving of the control has to be very swift, correct? And once this site is recovered, then it needs to be integrated back to the complete computation. Communication. Now, if we have remote or different machines having their own memory and resources, we need to pass messages to invoke some procedures. So message pass between systems is in the same way single computer message system does. So these function include you can transfer the file, you can log in onto the system, you can mail, you can invoke some function like the remote procedure call, and these functions can be carried out at longer distances, at remote site. Even you can exchange the information. And what is the advantage of these? First of all, there is a collaborative effort over distances. This distance can be 100 kilometers, 10 kilometers, 1000 kilometers, and this advantage will give rise to reliability. So what are the types of network-based operating system? They are categorized or generally categorized into network operating system and distributed operating system. So two general categories of network-oriented operating systems are NOS, that is network operating system, and DOS, that is distributed operating system. Network operating system, quite simple to implement this network operating system, but for users to access and utilize them, it's somewhat difficult than the distributed operating system. So it provides a complete environment. Here the users are available, or the information is available to them that there are multiple machines and they have remote resources on each machine. Remote login in network operating system, say you have a telnet. So internet provides a telnet facility for this remote login. So remote login say this is telnet and this is some site. So it creates a socket connection. What it creates? It creates a socket connection. We are talking about telnet, remote login. So between the local machine, if this is your local machine, say this is your local machine, and this is say this site where you want to reach. So it opens a bi-directional connection. You can enter username password, or you can either go anonymously. So user now here can execute any command on this remote computer. Maybe you are in India and this is in US. You can execute any command on this remote computer just like you are doing it here. Now remote file transfer. Every system has its own local file system. So we need some password, say, or we need some anonymous way to enter. So if we are going anonymously, we will access only the public available access, that is the access being provided to us. And the internet provides this FTP program, like the connect. You connect with this, but you say here FTP. This is the file transfer protocol, and you can just transfer the file, like get some file. You can just get it, and you must know where the files are in the subdirectories. This is how you do the file transfer remotely. And this may happen that various files can exist, and if there are various files, then inconsistency needs to be taken care. And only predefined set of file related commands can be used, like the get, like the put, ls or dir or cd. So this get, this is from remote to local machine. Put is from local to remote machine. ls and dir, this is listing of file in current directory of say remote machine, and cd is changing the current directory of the remote machine. A window user can log into the Unix system. Window user can log into the Unix system using the telnet, and it may change the paradigms. So user must use the Unix command here. And distributed operating system address this kind of issue which I just told you. Distributed operating system. As we have learned about network operating system, DOS or distributed operating system, it provides more feature than network operating system. Users are able to access remote resources just like they are local, and the data and process migration is under the control of DOS. We'll talk about this data migration and process migration. So what is this data migration? if say you as a user need to work on a remote file, this is very remote. So what you can do, you can transfer the entire file to the other side and modify the file. You can transfer whole of the file and modify. This is quite inefficient, because if you just want to change a small part, then there is no point in picking up the whole file. But if you want to change the whole file, or part of whole file, which is quite significant, then it is good idea to bring this file, right? The other thing is, if this is a file, just transfer that portion which is required. So just transfer only that necessary portion of a file which is needed for immediate task, and if other portion is needed, now take this, and this can be transferred. And after the modification, only that part which you have taken can be written back, transferred back. Computation migration. Now you want to compute something. So you need to invoke certain functions or procedure at another site, and then you have to get the result. So this you can done by RPC, that is remote procedure call. So access to file carried out remotely is computation migration initiated by the RPC. So RPC, it uses the datagram protocol, that is UDP, user datagram protocol on internet, unlike the TCP, and which is used to execute any routine on the remote site or function or procedure. And you can also send message to remote site. So now remote site now opens up a new processor, it will execute the task and send back the result, and it will close. And there can be concurrent and bidirectional execution also between the sites. This is also possible. When we talk about process migration, so this is just a extension of computation migration, and this, why we need it, process migration. Why we want process to be executed at different sites? Because we want load balancing. That means all the sites should have even balance. Then we want these computation to be speedy. That is, we want to reduce the total process turnaround time. And we have certain hardware and software preferences. We need specialized hardware or software. We need specialized processor and hardware. For software, we want some specific software to be dealt with, and which is cost effective also. This way is cost effective. And when we talk about data access, if data has to be moved, then the remote processes can be more efficient. This is process migration. So there are two techniques to move processes in a network. When we talked about the procedure, here we are talking about the processes, and processes are simply the program under execution. First thing is, the system may hide, it can hide the fact that the process has migrated from the client. It has migrated from this is client, this is say remote. So it can hide. So no user programming is needed to accomplish this process migration here. The second thing is, now the user explicitly specify how the process should migrate, and this is just to satisfy our preference for certain hardware or software. Then we come to the network structure, because on the distributed operating system or network operating system, the basic thing comes is network structure. So there are two types of network, LAN and WAN. LAN is local area network, WAN is wide area network. What are the difference? Difference is basically of the geography or the distance. So the difference is the way they are geographically distributed. For example, LAN. LAN is for small areas, say inside a building, or this is a premise. We have adjacent building here. For this we use LAN. And if we are talking about country or a large area, if you talk about India, it's a large country. So for that we use WAN, wide area network. And it depends totally on the speed and reliability of the communication network, how you specify your task and generate and complete it. So local area networks, this has emerged as taken place of large mainframe computers. We don't need these now. So we have number of small computers, they replace the mainframe computer. And so small computer, they have their self-contained application, and now they can be used for data sharing in the enterprise. And for a small geographical area, this is designed. We can use the multiple access bus, ring or star network. And since these are closer, inside a building or a premise, it gives you high speed, and the error rate are also very low as compared to the WAN. Most of the time, the twisted pair fiber optic cabling is used, but Wi-Fi are also used now. So you get a very good speed. So here we have now computers, we have certain peripheral devices, or we have gateways also. So these are the applications. So say this is a gateway. These are different workstation application server. Along with this, with the gateway, they are connected with printer, laptop and file servers. Wi-Fi is also an alternative of Ethernet, somewhat slower, but still it solves the issue or problem. And the distance between the wireless router and host also will influence the speed of the network. Then we come to wide area network. So WAN, wide area network, is for the computation of larger sites which are at the geographically larger area. So the communication processors here, we have specific communication processors that would control communication link. If you see this diagram, these are CP, 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 CP. All these are communication processors. And these CP, they are responsible for defining the interface through which the site will communicate over the network. May it be a network host, may it be some other user processes, may it be some other host. As well as it tells you about the transferring of information among these various sites. And links are geographically separated with a long distance, and there are point-to-point connection over long haul lines. Often we use the phone company lease line. Speed is quite, not as high as LAN, but substantial. And if you want to broadcast, then it requires multiple messages. And usually we have nodes, we have high percentages of mainframes.